In this video, we'll continue discussing query processing. In the previous video, we saw how the overall query processing high level, what the high level steps are, and we looked more specifically at sort merge algorithm and how it's used for select operations. Now in this video, we'll look at the other kinds of operations like join and project, and how the same sort merge algorithm is used for them. So whenever there's a join operation, there's different kinds of join operations. It could be an equi-join, which is also known as a natural join, which we've seen. It can be a two-way or multi-way joins, and join is one of the most time-consuming operation in query processing, and it needs to be carefully optimized. And so a lot of time, so there's a number of algorithms to handle the implementation of joins. So some of the different methods. The first one is nested loop join. So basically this is our brute force method, wherein we have our two relations that are being joined, and basically in a nested manner, every tuple of the first table is compared with every tuple of the second relation, and so on. The second method basically uses indexes. If indexes have been set, then they are used in the join operation in order to make the join more efficient. Sort merge technique is used here, can be used as well, wherein we first pull in all of the data from both of the relations, sort them, and then merge them in doing the join. A fourth method is by using hash keys and partitioning our data based on those hash keys, and then performing the join. So here's the algorithm that shows how the join operation is implemented. So basically what we want to do is a join of R and S based on the attributes A and B. So we're looking for equality of A and B. So we're joining on that column. So what this involves is basically you sort all of the tuples in R first, and then sort all of the tuples in S. That's before we do the join, and then we start comparing the rows of R with S. So the way it works is we first now, because they are sorted, it makes it easier. So we look at the first tuple, the A value of the first tuple in R, compare it with the B value, and if it's greater, then if the one in R is greater, then we just move to the next tuple in S, and to the next tuple, and so on, until we find a matching tuple. And then the moment we find a matching tuple, so that combined tuple is then stored into the output, and then we move on to the next tuple, and so on. So that's how the join operation method is implemented. So basically the next one that we need is projection, and the implementation of projection. So typically all of our queries, once we've performed a join, then we want to pull out, we're interested only in certain attributes of the table, and we can get rid of the other columns. So basically that's what projection does. So we basically create the list of the attribute list that we're interested in, and pull out just those columns from the relation, and then any duplicates are eliminated at the end, and finally the result that we get is the result after duplicate elimination. So that's the general algorithm. A third one that you see over here is basically the algorithm for union. Say that the union operation, you want to combine two relations R and S. This involves the bringing the tuples from both of the relations into one. So again, we did this just like in join. First, both R and S are sorted. The tables are sorted, and then the two the tuples in each of them are compared, and then if wherever they are equal, so we don't want to bring in duplicates, so we want to make sure that there are no duplicates, and so any of the duplicate tuples are eliminated. But whenever we see a row for the first time, it gets added into the output table, and so on. So that's the union operation. And in a similar way, we have the intersection operation, where we want to keep only those tuples that are common in both both the tables. So again, we perform sorting first, and then the intersection is checked for. So both of the all the tuples of both the relations are checked, and whenever they're equal, we put them into our output table. And then the next set operation that we commonly have is the set difference, where we want to keep only those tuples that are in R but not in S. So very similar to the union and intersection, it's just that in our do while loop, we're going to do it a little bit differently. We start out by sorting, and then we keep only the tuples that are in R and not in S. So basically for each Ri, we are looking to make sure that there is no match in S. If there isn't, then it goes into the output. So basically, again, the buffer space is important for join algorithms, and it all depends on how much buffer space there is available, and certain optimizations have to be applied based on how much space we have, and that's where the underlying algorithms of the sort merge come into picture, which will adjust the way the blocks are treated based on the buffer space. So just like we have the selectivity ratio, there's also a join selection factor. So basically, and this is used in optimization. It involves looking at the fraction of records in one file that will be joined with the records in another file. So how many of them will pass the join condition. So basically that's the join selection factor, and based on that, because we want to avoid dealing with a block of code that has lots of tuples at the beginning. We want to eliminate as many tuples from our search as possible, as soon as possible. That's the reason we are looking at these selectivity ratio and join selection factor. It also so the join selection factor also depends on the type of the equi-join condition. So we look at that, the optimizer looks at that equi-join condition as well, and then based on that decides on what's best for in terms of join performance. There's also the partition hash join, where each file is partitioned into m partitions, and they use the same hash function, and then that hash function can be used on the join attributes as well. So basically, when these partitions are done, each pair of corresponding partitions are then joined. So that's how the partition hash works. And then there's a hybrid hash, which is a variation of the partition hash, and then the joining phase of the partitions is included in the partition itself. So this is a hybrid one, and again, the reason it's there is for better performance. The goal is to join as many records as possible during the partitioning phase, and then so that we can save cost of storing the records on the disk and then rereading them. So like I said, our goal is to get the number of tuples that we need to deal with. We want to that set needs to be smaller so that the cost of storing it and rereading it is as low as possible. So that's what's done. Now similarly, like we have the algorithms for join and we had for select, there's also algorithms for projection, for the projection operation, and then here our focus is on just selecting specific columns from our list of attributes, and then any duplicates are removed. Now, but then with the duplicate removal also, we should remember that for SQL queries, the default for SQL queries is there is no elimination of duplicates unless the keyword distinct has been specifically included. So again, depending on, so that's the default for SQL. Then depending on the database management system settings, the algorithms will work accordingly and deal with the duplicates. So we saw that there are different algorithms for all of the set operations: union, intersection, set difference, and join, and that's what we saw in these slides today. And then there's sometimes these set operations become very expensive to implement, and that's the reason we have these different techniques that we can use. There's the sort merge technique and a hashing technique for obtaining better performance and efficiency of the queries. So now here we'll look at anti-join and how anti-join can be used for set difference. So this is again in SQL wherever we have the except or minus. So that's what is set difference in SQL. In relational algebra, set difference is the difference operation, whereas in SQL it's basically the clauses except or minus are used. So an example would be, say we want to find which departments have no employees. So if we write the SQL query for that, it would look like this. We want to select the department number from department where there are no employees. So basically we're using the minus operation, and on the right hand side we have select department numbers from employee. From the employee table we are pulling the department numbers. So what we have in here are all the departments with employees in them, and what we have on the left hand side is all the departments. So basically when you remove departments with employees, then what we get are the departments that have no employees. So this involves that minus or the set difference operation, and what this will internally convert into is this anti-join operation. So it's equivalent to writing select distinct department D number from department and employee table, and then we are joining the two tables using an anti-join operation. And what that means is, if you remember, when we are comparing the left side tuples with the right side, each left side tuple is compared with the right side. The moment a match is found in the right side relation, the tuple from the left side is rejected. So that's how, and that fits perfectly for our set difference operations. Now there are also aggregate operations like min, max, count, average and sum, and these are computed. Again, these can be computed by doing a full complete table scan, or if there's an appropriate index, then the index can be used. So say for example we want the max salary from the employee table. Now a good way to do that is, if there's a B plus tree index on salary, on that salary attribute, then it's basically going to be simple to find that max salary. We basically have to search for, or basically go to the rightmost pointer in each index node, starting from the root to the rightmost leaf, and that's where we'll get our max salary amount. So there's average and sum. Again, indexes can be used if there is a dense index set. So depending on what kind of index is set for the table, the query processor behind the scenes will then use the appropriate method and determine these aggregations, like an average or a sum, or counting. If counting needs to be done, and if there is an index set for the attribute, then it's basically just computed using that index value. As we can see, so there's different kinds of joins. There's a standard join, which is called our inner join. So that's the standard one. But then there are a number of variations of it, like the left outer join, or the right outer join, or a full outer join, and then there have to be corresponding implementations for that. Here's an example of a left outer join, wherein we want employee's last name, first name, and the department name, and we want to left outer join an employee with the department on the department number. The reason we are doing a left outer join here is we're interested in keeping only the tuples from the left table after the join is done. We're not so interested with the right. So wherever there is a match, we're going to keep those left side tuples. That's what our interest is in. We saw semi-join and anti-join as well. So that's basically used for the exists or not exists kind of operations in SQL. So to summarize, basically what we saw is how the query processing happens, how the SQL queries are first translated into relational algebra, and then how the sorting, there's a sort merge algorithm that's used to handle because there's limited buffer space that the DBMS has in order to do all of the processing. So there's this sort sort merge algorithm that's used, and then we saw how the different operations that we have, like selection, join, projection and aggregation operations, how each of them are implemented within behind the scenes, so that the data can be fetched in the most efficient manner. So that's what query processing basically involves. That's all I have in this video. Thank you.